Okay, this is the last video, I think, if I can make this not too long, for my Calculus 1 Optimization Lab number 1. This is 5 and 6. These are the last two problems on the lab. So here number 5 is, it says, if a box with a square base and an open top is to have a volume of 4 cubic feet, find the dimensions that require the least material. So first of all, I drew my picture here. You can see because it's a square base that I have x times x for the base, and I just called h for the height because they didn't say anything about the height. And they said the volume has to be 4 cubic feet. So first of all, I know my volume is going to be my constraint because they told me what the volume had to be. So I know the volume of the way my picture is labeled is area of the base times the height. So the volume is going to be area of the base times the height, or the volume is going to be x squared h. And they told us the volume has to be, what they say, 4 cubic feet. So I'm going to put it equal to 4. Okay. Now the objective is find the dimensions that require the least material. So the least material right here is our surface area, or cardboard, if you will. So it's our surface area, or the cardboard, or whatever the box is made out of. And the surface area, if we look at it, is I have the base, so the surface area or the material is going to be the area of the base, which is x squared. And then I have a side here that's x times h, and I go all the way around, and they're the same because the base is square. So that's going to be 4 times xh, because each side is, the area is xh, and I have 4 sides. Okay. So, and they want us to have the least material. So we're going to have a minimum here. So we're looking for the minimum amount of material. All right. So I kind of have Christmas colors here. I didn't intend that. What I would do here, so I could get this all in one variable, is you want to solve for one here. And I'm going to tell you, you can solve for x on this, but you'd have to take a square root. It's just harder math. You can do it though. I mean, but I just solve for h, which is 4 over x squared. And then I'm going to take this and put this in the h spot over here, okay, so that I can get my surface area all in terms of one variable. So I have the surface area is going to be x squared plus 4x times 4 over x squared, okay? So the surface area is going to be x squared plus 4 times 4 is 16, and this will cancel out, so I just have an x in the denominator. So I'm going to write it like this. The surface area is x squared plus 16 times x to the negative 1. So right there's our surface area equation. Now I'm going to change this because remember, if we want to find minimum or maximum types of materials, we're going to have to put our first derivative and put it equal to 0. So I'm going to do s prime and put s prime and put it equal to 0. So s prime is going to be 2x minus 16 x to the negative 2. Let's just put it right down here and put it equal to 0. So I actually just did the first derivative. Now we're going to go through and solve for this. So I'm going to move this over to the other side. So I have 16 over x squared equals 2x. I'm going to cross multiply. So I have 2x cubed equals 16, or x cubed equals 8. So I have x is going to be plus or minus 2, but I'm just going to say 2, and I'm going to talk about feet, because negative is nuts, because we're talking about a box, right? Before we go any further, I want you to make sure you do your S prime bar, put the 2 in there, and I want you to use right here, or put this in your calculator, and go to the left and the right of 2. If I go to the left of 2 and say pick a 1, that's going to make this negative. And I'm going to put a negative here. And if I go to the right of 2, let's pick 3 or 4, this is going to make this positive. Okay. And so this is truly a minimum. So they want to know, find the dimensions that require the least amount of material. So I know x is going to be 2 feet by 2 feet, and I have to do the height. So right here's the height equation. So height, all right, is going to be, let's look at it. H is going to be 4 over 2 squared, or 1 foot. So there's my height, is 1 foot. So I'm going to come up here and they want to know the dimensions. So it's going to be 2 feet by 2 feet by 1 foot is going to be the dimensions of my box that will require the least amount of material. Okay, let's try the very last one on here. This is a metal cylindrical container with an open top. So I tried drawing it for you to hold it 1 cubic foot. 1 cubic foot. That's volume. That's our constraint. That's all it can hold. Okay? If there's no waste in construction, find the dimensions that require the least amount of material. And I gave you a hint here. Well, first of all, material is surface area. And the only difference about this instead of a box is we're looking at, think of it like a can, the surface area, okay, and it's got an open top. So we're only worried about one bottom and all the sides. Well, the constraint volume is easy. I know the volume of this is going to be the area of the base, pi r squared. Whoops, I talked about it and said it wrong. Pi r squared is the area of the base times the height. All right, so that's my volume, and I know it equals 1. So pi r squared h has to equal 1, because that's what they said. The objective is the surface area. So I kind of have the surface area equation here, but I want to show you where it comes from. So the surface area is going to be the area of the base. There's the pi r squared. I kind of get that. But then how'd they get 2 pi r h? So I want you to think of it. I'm going to kind of do it over here. What if I peeled off, pretend this is a soup can, I peeled off the label. Wouldn't the label look like this if I peeled it off? So I have the area of the base, that's the pi r squared. If I do this length here, isn't that the circumference of a circle? And I know circumference is 2 pi r, and this is the height. So this is the area of the label, if you will. This is where the surface area came from. So now I know my surface area equation, okay, is going to be pi r squared plus 2 pi r h. Okay? Again, when you go to solve here, you could solve for r. Pi is a constant. I'm just going to solve for h. So h is going to be 1 over pi r squared. I know it's not pretty. It doesn't matter. You're going to take this and put this in the h spot way over here so I can get everything in terms of r's. I get there's pi there, but pi is like a number, so that's not a problem. So I'm going to do s is going to equal pi r squared plus 2 pi r times 1 over pi r squared, okay? Now let's simplify this. So I have pi r squared, and the pi's kind of cancel here. The r cancels, so there's only 1, and so I have a 2. So it's going to be 2 over r, okay? So let me get the right color here. Plus 2 over r. So we're at least in terms of r, so I'm going to write the surface area as pi r squared plus 2r to the negative 1. That is our surface area equation. Now remember, in order for us to find the least amount of material, all right, we have to do the derivative. So we're going to find s prime, because you have to do f prime of x has to equal 0. So when I do s prime is 2 pi r, that's power rule, minus 2r to the negative 2. But how about we put that right underneath? Okay, let's do that. Put it right over it. It's going to be 2r to the negative 2. Let's just write it down here and put it equal to 0. Okay, so now I'm going to cross multiply after I move this over. So I have 2 over r squared equals 2 pi r. Cross multiply. I have 2 pi r cubed equals 2. And we're solving for r. So r cubed equals 2 over 2 pi, or 1 over pi. So r cubed, or the cube root of r, is going to be 1 over pi raised to the 1/3. Because what I'm going to actually do is raise each side, or cube root, if you will, both sides, so that I can figure out what r is. Which the cube root of 1 over pi isn't pretty, guys. It is. I'm going to do 4 decimals, 0.86827, and this is in feet. So that's how many feet the radius has to be. Before you do anything further, I want you to do, ready, is we're doing our S prime bar, and we're going to check to see if 0.6827, or basically 1 over pi, the cube root of it, or raised to the third, if you will, is a minimum. This one I would strongly suggest that you either put this in your graph and ask your calculator, just because, right here, and you're going to go to the left and right of 0.68. When you do that, you're going to get a negative numbers here and positive numbers here. So this truly is a minimum, okay? Now they want us to find the dimensions. So I do know the radius. It's not pretty, but it's 0.6827 feet, okay? It's 0.6827. So I know what the radius would be. But now I got to find the height. So what you need to do is say the height is going to be 1 over pi, and it's going to be 0.6827. That's a 7, guys. That's messy. 0.6827 squared. When you do that, the height comes out to be, what does the height come out to be? 0.6830, okay? So, feet. Now this isn't feet. Forgot to label it. So the height is 0.6830 feet. Not pretty, but we can convert that to inches if we had to, but they just asked for the dimensions, and that's how you would do that one. So I hope these two help. I have finished the lab.